And we're going to continue learning Python. And I'm hoping, I'm pretty sure we'll get that far, is I want to get down to the if, else, while, for loops and give you an assignment where you're using the for loop and while loop to create something. So, okay. Last time we were talking about what these meant. Boolean member is true and false. So this right here, 10 is greater than 9. 10 is greater than 9, so that return true. So that print true. 10 is equal to 9 is false, so that print false. And 10 is less than 9 is false, so that print false. Now the goal of the booleans is to simplify some of your coding, so that instead of putting a equals this value, you can simply say if true. So if not done, while not done. So make it very easy, almost like the if statement or the while or for is human language. And the second purpose of it is not to take up as much memory. So instead of declaring an integer or double that you're trying to keep track of, or a string that you're trying to keep track of some value with it, you can keep track of it with a boolean, which takes up less, like I say, less memory. Now here we got an if statement. If B is greater than A, then we print B is greater than A, else B is not greater than A. It could be over in Blender. Could be over in Blender. You want to keep creating cubes until you the value is greater than a certain x value, y value. So you can do an if statement, and you keep adding on that until it's greater than x is equal to 5, y is equal to 3, so forth. Now you might say, "Why don't you just hard code that? Tell it how many cubes to create." Well, maybe you're getting that from the user in some manner, so they're inputting those values, so they're not hard coded. So you're doing an if statement. Now, in conjunction with that, you could do a while statement. It all depends upon what you're trying to achieve. The thing about programming is it opens up so many more doors than just standard Blender commands. Some of this isn't as important. I don't think you ever use a Boolean, evaluate a string and a number. This is some of this is just kind of very distinct applications, unique applications that would require these. And we'll talk about functions down here, so we'll talk about that. Okay. Some of these we've alluded to, Python operators, x plus y, x minus y, x times y, x divided by y. This is a modulus, which returns a remainder, exponential, and then our floor division. Remember that with your console here, it shows you different items. Like if I grab this and moved it over, then it shows you the commands that I just did. And let me choose a new script here and import BPY. I remember right. And So if I wanted to move something to a different location, I could use this command. I did my left mouse button, dragged, and then dropped it up here, so it copied everything on those lines. I'm gonna do a Control C, come over here and do a Control V. And you notice that this says transform.translate. Well, that corresponds. Let me get to this. Go ahead and save that. Looks like I got something already there. Save as again. Okay. I highlighted it and then I did a Control C. Really? And then you did a Control V over here. Go ahead and share your screen. Now, just delayed. Okay. Sometimes Blender's kind of weird also, unless your mouse is actually in a window. Sometimes the commands do not apply. So if I didn't have my mouse down here and when I did a Control C, if I had it up here, then it might do something different. Okay, go to layout here, and we got our cube. And notice over here, in our context, this orange square, you see you got your transform location. So that's corresponding directly to that. And so when you're manipulating that with code, you're altering these values. Just the same way we'll see that you can alter the rotation and scale. Pretty much, I shouldn't say pretty much everything, but a lot of the items over here you can change programmatically. Okay, click scripting to go back to there. Now, not all of this is necessary. We got a lot of different items here, and I don't know how to make that wrap, to be honest. Oh, Google app, because that's gonna drive me crazy while we're coding. I can't go back and forth. Blender scripting, how to wrap the code window. Following three buttons display options, line numbers, word wrap text, and syntax. Okay, it must be those. Word wrap. There it is. That's what I wanted. Now I'm gonna try to get rid of some of this. See if I can mess it all up. With programming, you have a beginning parentheses here, you have to have a closing parentheses. You have a beginning one here, you have to have a closing one. Okay, so then let me change this to a +7. To save, and then I'll click run. And run it again. See, this is adjusting it. This isn't the absolute value. This is adjusting it based upon where it's currently located at. But you can see I did not need all that extra information because it defaults to whatever it was originally. When you're doing a capturing the command down here, you can use everything, but realize probably only the part that you're changing is the one that's actually needed. Some people write special scripts to set everything back. Like they'll put 000 here and set it for the absolute value. I still haven't figured out how to clear this console down here. Maybe highlight it. It's kind of hokey, but I was just clicking it and pressing delete. Now let's try to change it. Like up here, I got this selected. I do in and change my location here. See if I can figure out how to do the absolute value without actually looking up the documentation. Okay, so do an in to get that to disappear. Oops. Escape. There we go. And you see it comes up with these commands. Context object dot location. So it's not doing a translation. This is actually putting it back to 000. So if I put them rectangle around that, got those highlighted, do a Control C, and I come over here and do a Control V, do a G for grab, move that over here, and I run my script. Then you see it sets it back to the absolute positioning of 000. Now I realize this is based upon whatever you have selected. Later on, we're going to see how to programmatically choose an object. But if I had a different object, add mesh, the monkey, the G for grab, move it over there. Notice that I have my Suzanne selected. And if I click run script, it puts it back to the center there. Like I say, some people create scripts just so they can automate certain tasks. Like maybe doing things with the bones. You had there was some options we had where we had to select 2 or 3 different places, and if you had a bad memory like me, maybe you'd put that into a script so that you could, when you run that, it'll set all those items for whatever you have selected. Okay. Now there is and this I'll have to refresh this. But I have this going to 0, 0, 0. And let me do a Control Z, Control V. This will set it to 5, 5, 2. So I have Suzanne selected. If I run this, see, moved over there. If I run it now, keep running it, you do not see Suzanne moving to the center. There's a way to refresh your screen. But what it does is it just starts running here, and then the ending location is what the only thing you actually see in your script. Let's see if I can Google that real quick. Blender scripting, refreshing window. Tag redraw. We'll update. Okay, let's try that. Okay, so if I run that, it did go here, but then air it out. Didn't like something about that. Let's go to Blender documentation. We won't need that right away anyway, but I'm trying to see if I can, while we're here, scene update. And you'll find there's pretty good documentation on it. Some of it'll be a little easier to read than others. Hopefully this is where update is. If it isn't, I won't waste time on it all. Is that selectable? Yeah, it is. Okay. No, I doesn't have it there. Okay. I see. I'll come back and research that before we get to that point. This would be if you're trying to create an animation through code, which we'll eventually do, then you need to update it. Because if you have your object going around in a circle, you will not see it being updated along the way. You'll just see the end result. All we're going to do today is get to the point where we run a for loop and create a bunch of different objects. So, these ways, I think that's how far we get. Okay. We've already talked about comparison operators. Remember, equals equals. It's your equals. The exclamation equals not equals, greater than, less than, greater than equal to, less than or equal to. And then you can have an and or not in between them, like that. Now, an if statement in programming is the same as in real life. It's the same principle. If when I leave tonight, if I'm hungry, then I'll go to McDonald's. So if hungry equals true, then I'm going to McDonald's. If I'm not hungry, then I'm not going to McDonald's. So you can program it like if hungry, go to McDonald's, else go home. Well, maybe I don't have money. So So that'd be like an and. If I'm hungry and I have money, I'll go to McDonald's. Same principle that we do in real life is how we apply it in Python or programming in general. The or. If if I go someplace and they have a cheeseburger or or a hamburger, if they have either one of those, then I'll order. If they don't have that, then I won't. So that's an or. Either one can be true, and not just negates the entire statement. And identity, not so important. Membership, we haven't talked about those yet. Bitwise, no. Okay, let's go down to the FLs. And we got all of our operators like we talked about. And as we indicated earlier about our if statement, this is the format of it. So for example, if sales equal to 100, costs is equal to 50, and I might mute you a little bit, Kyle. Your feedback's coming back pretty good. Okay. Let's see. Well, that's bad. I can't think of any business formula. Profit is equal to revenue minus costs. Okay, that's one. Okay, so let's say revenue is equal to 2,000 and cost is equal to 500. So then profit is equal to revenue minus costs. Now, first off, let's talk about this. Let me print profit. Tells us 1,500 over here in this window over here. I can't make that bigger. 2,000 minus 500. Now, when you say revenue is equal to 2,000, this is declaring a variable and it's storing 2,000 into it. So when I declare a variable, it's set inside memory space. So, and that memory space is given to Python by Windows. Windows says you have this block of memory where you can store stuff. It's kind of given the program its own little locker of memory. And then Python runs across the first variable here called revenue. And it says, okay, I'm given this bit of space from Windows to store my items in. I'm going to put revenue right here in this spot. So it handles the allocation of where it wants to put it at. Now, it does it not directly like you might think, but goes through machine language, a lot of different hoops to get there. But you can think of it logically in that manner. And then it said, okay, I'm going to use this memory space right here for revenue. When it hits 2,000, it puts 2,000 in that location. Now, when it and this is not only declaring the variable right here, but it's also assigning it. Some of the variables have certain types associated with them. If you got a number with no decimal, it's referred to as an integer. And integer has so small of a number or so big of a number you can store into it. And where that comes from is when you declare something as an integer, it sets aside so much of that memory for that variable. And if you enter a number bigger that will not fit into that with all those ones and zeros or the corresponding hex, then it exceeds what's been allocated in terms of memory. So um, probably more than you need to know at this point, but just there's limits on it. Then it takes costs, assigns a value to it. And again, it assigns a memory for the cost. You don't have to worry about that. It's all done behind the scenes and sets it equal to 500. Both of these are assignments are being done. This is not the equals like you'd see in algebra. So then it comes down here. It says profit is equal to revenue minus costs. What it does, it approaches it from the right-hand side. It goes and retrieves the value of revenue, which is 2,000. It plugs 2,000 in for here. Minus, and then it goes and retrieves the value that's in costs, which is 500. And then 2,000 minus 500 is 1,500. It follows your order of operations, and then assigns it to profit. Programming-wise, this is perfectly acceptable. Let's say that they're going to add $100 on to profit no matter what. So this goes, gets the old value of profit, which would be 1,500, adds 100 to it, 1,500 plus 100 is 1,600, and then assigns it back to profit. In algebra, this would be no solution. Because if you took the profit over to the left side, you get profit minus profit, which is 0, 0 equal to 100, which is false, or no solution. So again, the equals, in this case, is an assignment operator. If you wanted for an actual logical check, is this equal? That's what they're talking about with the up here in the operators. That's why we have to put 2 equals. So this right here. And you notice that they say up here, all of these are assignment operators. So just not the equals, but all these different forms. Okay, now my if statement. If profit is greater than 300, then I can do something. In this case, I'll just print. Profit is greater than 300. Now, when I do an enter, and it's indented like this, then to get it to go back, you just do your backspace, as you might imagine. If I keep typing things here, it'll be like if I did a print here. Print another line. And I'm going to put that's there. Now, if profit is greater than 300, it'll do both of these lines. If profit is not greater than 300, it will not do either one of these. So the indentation is how it controls what gets run when that is true. In Blender, let's see what it does. If profit is greater than 300, you notice there, it did the indentation automatically for you. Do not put any extra spaces. Do not do any backspace. Where that's at is where you need to put your line of code. Have a drink here. So if I run this, see down here, move that. It says 1,600, profit is greater than 300, and prints another one. If, on the other hand, I had taken this and went back, let's see what it does. Indentation screwed up, and it gives you an error on that. If I had went forward one, and run it. Again, indentation. So you can't put extra spaces for that indentation. Indentation has a very specific meaning in Python. If I go back to the beginning like this, that's fine because that's where it expects it. And now if I had this is 1500, 1600. So if this is greater than 1700, then I run it. You see, it does not print. Profit is greater than, well, 300. It doesn't print that. It comes down. It evaluates this first. Specifically, it goes and gets the value of profit. Well, 2,000 minus 500 is 1,500 plus 100 is 1,600. So it plugs 1,600 in for profit. And then it asks if that's true or false. Profit is greater, or 1,600 is greater than 1,700, which is false. Since it's false, it does not do this line of code right here. It instead drops out down to the next line and continues on, which is this one. Does that make sense how the if works? Okay. Um, with an if statement? Um, you really wouldn't. You could, but it would be real clumsy, assuming Python supports it. Oh, horrible. While we're on it, let me go ahead and do it. Python labels. Ooh. Label colon. Okay. So this loop colon. Go to one word. Now, what this will do in theory, and I'll play with this more, but and this is how programming languages used to do loops. Um, I shouldn't say used to. They've had a while and for as long as I remember. But this is how we used to do some loops sometimes. There's a horrible way to do it. You have a label here, and it's labeling a piece of like the start of something. Come down here, you do some kind of check, and then at the end you do a go to loop. And so it comes up here and just goes up to here and just keeps looping over and over like that. Now the hope is that you have some kind of break in here to break out of it. Like here, see how they're doing a check? If A is equal to 2, then they're doing a go to. So let me show this. If I had a counter, counter is equal to 0. Within my loop here, that's curious. I wonder if I need the indentation. I'll leave it there. Counter is equal to counter plus 1. If counter is less than 300, Then I want to print counter. We haven't covered the else yet, so I'll skip it. But if counter, actually, if it's less than 300, I not only want to print it, but I want to go back to loop. Okay, let's see if I just run it up in a loop. Okay, less than 300. It's less than 300 initially. I should print it, go back to loop, come back here. I should increase counter. Okay. Yeah, maybe can't do labels. Oh, yeah, it's down here. I don't know. To be honest with you. Label dot begin. Go to. Okay, let's try that. Label dot loop and go to dot. Unexpected indent. Sometimes it's best to go to the previous line and just press enter, because then you know exactly where you need to delete it back to. Then the trail like the go to there, but let's try running it. Label is not defined. So you had to do that in Python, huh? It's an interesting thing to have you do. I don't know the answer to that. Typically, when you want to loop, you just do it the while of for. This is how I first started programming back, 25 years ago, I guess, 30 years ago. I guess it's about 30 years ago. Is at Koch Industries, they wanted us to use go-tos. And you'd have to have a label up here of some sort. And then you'd have some kind of check. And then your go-to would loop like that. They liked that because they could see everything all in one place. And I don't think COBOL supported a while loop or a for loop, if I remember right. If it was not encouraged to use it. Now you can also, in the if else section here, besides just do a straight if, you can have an elif. So it checks to see if this is true. If that's not true, it comes down here, this elif, and then checks to see if that's true. So for example, if I had I was trying to think what I had for my example. Revenue and then costs, no memory. profit is equal revenue minus cost. If profit is greater than 300, then print greater than 300. Come back here, you do an elif, profit. This is equivalent to other programming languages where you have an else if. If profit is less than 300, then print less than 300. And then if I do it back, well, we haven't seen it yet in the W3 schools yet, but there's an else that goes along with it. Print equal to 300. Printf. I'm not in C or Java. Let's try that again. Print. Okay, so this comes down here. This checks if this is true. If it's false, comes down here and checks if this is true. If that's false, the else is the default. So if none of the above is true, it automatically do the else. That's how an if-else works. And that's probably about all exciting part on that. There's shortcuts, ways of doing it. I don't like what they got there, but you can read that if you want. Do an and or. We'll see some of that through actually coding in Python or Python in Blender. We got while loops and for loops. I'm going to start with the for loop. It's the easier one. Okay, so if I wanted to loop number-wise, this for x in range, and that says 6. This goes from 0 to 5. It goes one less than the number you have there. You see that indicate that there. The values from 0 to 5. So over here in Blender, let me get rid of these. And come down here and do some cleaning. Okay, so I want to show adding a cube on there. So I do an add mesh cube. You see the code right down here. If I click that and do a Control C, come up here, do a paste, Control V as in victory. And that's how we add a cube. Now let's say I want to add 6 cubes. I'm gonna have my for loop here, for, and what we're implementing is this exact same thing here. For x in range 6, and then press enter, then press delete to get that there. Now, even though this doesn't look like it's indented, it's actually all part of that one line. And location is 0, 0, 0. Well, if I could leave it there, and if I run this, let's see. You'll notice over here, it created a bunch of cubes. So it went through this and created that many cubes. If I wanted to create 1,000 cubes, I just need to change this 6 to whatever number I want. Now I put them all in the same location, like they're all right here. So let me You grab those and do an X for delete. Get rid of those. Now, maybe what I really want to do is I want to position them in different places on the screen. So, I'm changing X here, so maybe a logical change would be to put a variable here, like X. And if I run that, you see how it changes the X. Now, each one of these is a doesn't really show it there. You see how they overlap? This is going by ones. So what we really want is we want to go by twos. I have to think about this. I think if I put 2 times X here, I think that'd work. When you highlight those, press X for delete. Let me see. X is 0 initially. 2 times 0 is 0. Then it's 1. 2 times 1 is 2. Then it's 2. 2 times 2 is 4. I think that should work. Let's see. See how now each cube is still smack up against each other. You just have to keep in mind that the distance here is 2 units. Now, we could change other things as we went along. Like if we wanted to change the Z as it's going up. Let me highlight all those. By the way, there is a way, and I don't know how you select them all. But how you delete? Oh no, I mean through code. Sorry. Oh, does that show it? Okay, let me run it. Let me do select all or select the camera too, which would be okay for what we're doing here. Huh. It also select the light source. Oh well, I just for the time being just delete those. Okay, now if I want to change the Z at the same time, this is X, Y, Z. So I can do a 2 times Z like that. Then run that. Doesn't like something. 2 times Z. 2 times X. There we go. And so then you're creating kind of like a stairs type of setup. So yeah, you have total control over what you want to do on that. You just have to envision what can you accomplish with a particular loop. Now that's going from 0 to 6. There's other ways of doing a for loop, number wise. You can have a starting parameter. This goes from 2 to 5. It's always 1 less than 6. That just throws me all the time on that. But this would start with 2 and go to 5. There's even a way you can do an increment like this. This goes from 2 to 29, increasing by 3 each time. So it'd be 2, it would be first, then 2 plus 3 is 5, then 8, then 11, and so forth. So over here, instead of actually multiplying these by 2, I could have had this go from 0 to 6, and then increment by 2. And get rid of those. And I think you're right. I'm going to come over here and select everything, even though it'll delete the light source and camera. And this is one we want. What do you mean by delete vertices? Delete. Huh, mine didn't. That's weird. Oh well, I didn't want the camera and the light source anyway. Okay, so I didn't mean to do that one. Control Z. I would need to select this one, so I got that selected. Control C. Come over here. Control V, and choose the delete. Control C. Click over here. Control V. Now I won't have to keep deleting those cubes each time. So each time I run it, obviously I don't understand this. Oh, what did I do? Hardcode 2? That's nice. There. Okay, so starts at 0, then adds 2 each time. 2, 4, it doesn't get up to 6 because remember this goes from 0 to 5. Different ways you could do that. It's kind of your choice on that. Now let's say I also for each one of these x values, I want to increase it out to the y because I want three cubes going out to the y direction. So within this for loop here, I go to this line here. By the way, if I did make this small again, you would see that this is all one line indented that same way. It's only when I zoom this window, it looks like it's not indented. You can't do that. It's got to be indented, even though it looks like it's acceptable to do that. Okay, press enter. I do for Y in range, and I want 3 of them. So I can go from, let's see, 0 to 6, go by 2. I want to add more cubes. So I'm going to take this, copy that, Control C, come down here, Control V, and I can change the size here, can't I? So I can make the size 1, and I wouldn't have to worry about go by 2s. And let me think about this. X position I can leave as is. That's fine. The Z position I can leave as is. But the Y position, if I put a Y there and run that, then we create our set of 3 of them. And again, I know this looks like a mishmash of garbage, but if you actually zoom in, zoom out, I'm holding down my control key and do my mouse wheel, you'll see the indentation. And you'll see that this for loop here, this Y, is being done for each iteration of X. So it comes down here, it says X is equal to 0 initially, does this line of code, then comes down here and loops through for all of the Y's. And there's 3 Y's that get accomplished there. Is that confusing, that 062? Almost. It doesn't go to 6, it goes to 5. Always goes 1 less. Yes. Okay. Well, part of it is trying to figure out how can you create a certain shape. How could I then go down and have stairs going down on the other side over here? Well, let's think about that. Come down here, I need another for loop. Go backspace a couple times, take it back to the beginning. This takes it to 0, 2, 4. So my next one would be 6. For x in range 6, comma, and I want 3 more. So um, 12. 6, that's 6 to 11. So I got 6, 8, and 10. So that's 3 more. Specifically, what I want to do though is I want to start with 11 and go down to something. And this may take me a little bit of playing. I'll put, what do I put here? 7. Okay, let me think this through. Cube 1 is at x position, x equals 0. Cube 2 is at x equals 2. Cube 3, x equals 4. And that's based upon this for loop, this first for loop. And x3, since I want it going down, cube 4 should be at x equals 6. Cube 5 should be at x equals 8. And cube 6 should be at x equals 10. So I want for x in range 6 to 11, go by 2. Then I'm going to copy this line of code right here. Paste that in. Now, unfortunately, the Z is not correct, but let's just let's test that and just see what it looks like. I want to get rid of these now that I've wrapped my mind around what in the world I'm doing. Sometimes programming-wise, it's necessary to do that. There, just need to make more room. Now let me run it. And see how my X value increased? So that's perfect. That's what I wanted. Okay, now let me think about my Z value. Cube 1, Z is equal to 2. Cube 2, Z is equal to 4. C3, Z is equal to 6. I'm lying. 0, 2, then 4. So cube 4 needs to go back down to, or it wants to be 4. Cube 5, Z would equal to 2. In cube 6, Z would go back down to 0. Because we want it to come back down. Does that make sense on that? So what we're trying to accomplish here is we're trying to go from 4 down to 0. A real sharp individual could take the values of x and then come up with the value of z. I don't think I'm that sharp this morning. Sometimes I can wrap my mind around it. If you want to, do you see it? Say that again. Like that. So basically negative x. Would that help us with our z? Let me think. So no, it'd be too big then, because since we want z to be 4, and my first one is x is 6, so if I did a negative x, it'd be negative 6. Now, brute force, this isn't the best way, but since I can't wrap my mind around it, the brute force, I can say z is equal to 4 initially. And then down here, I'll put z in here. And then z is equal to z minus 2. That will accomplish it. It's kind of sloppy programming. Like I say, people that are clever can think of these x values here. What math calculation could I do to it that didn't affect the z? And you see, it wasn't that hard to do the z's, was it? Now you notice it doesn't go all the way across. So we're going to want 3 of them across. And so that's my y, which is this bit of code right here. So I'll do a control C on that. Then come down here, press enter, and do a control V. Okay, X would be right, Y would be right, Z here would be wrong. I want that to be Z, like that. And then I'll run that. And I don't got something right. Oh, yeah, you're exactly right. Yeah, that right there should not be there. It should be after this. Now I can't have it indented there. I have to go backspace and put it right there. And now I run that. And we just created a stairs going up like that. And this here is now hard coded for values, but I could equally have set variables up here such that I could have it create whatever amount I want. Lots of different things you can do with that. Is there any questions on any of that code there? Now, what I want you to do is I want you to create a pyramid using code. Now, it should be a block pyramid, and I'll show you what in the world I mean by that. Let's see. X, delete. Yes, but it doesn't have to go smooth like a regular pyramid. Let's see, cube. Where is the modifiers? Array. It's 5. 9. And it's your choice on numbers. 10 there. Add another modifier. And change this to 10. And I don't want you to use the array modifier, by the way, because we're just learning the for loop. There is, see how the modifiers here? You can program that. Pretty much everything you can do in Blender, you can program. And even more than that, you have complete control over the variables over here. So in some cases, it makes it easier. Okay, so that's our first one. Then I add mesh, UV sphere or UV sphere cube, and I want to move it up like that. And what was the last one? 10 by 10. So add modifier, array, count is 8. And then add another array modifier. And it's going to be based upon the y. So I need to put a 1 in for the y. And change that to 8. Zero, zero, 1, 2, 2. See, and then it goes up like that. Does that make sense on the shape I'm wanting you to achieve? Okay. And that's the assignment. I want you to go through and using code, create a pyramid as best as you can. If this is your first, I know Kyle, this is not your first time, but some people this is their first time doing code. It's a challenge. If you don't got it perfect, my grading is not harsh on that because the more and more you do it, the better and better you understand it. So you go create the Dropbox, and I wouldn't stop the recording. You can have the rest of the time to work on that.